Okay. Okay, so what is space complexity and time complexity? Can you explain?
Yeah, time complexity means suppose we write any algorithm or any code we write, so how much time it will take.
Mm-hmm.
So the same algorithm or code can be written using many ways, right? So this time complexity is the way to find out the most efficient code or algorithm. So
Mm-hmm.
suppose we write any for loop or something. So no, usually it takes O of n, and if any balance tree and all is there, then it is O of log n. So O of 1 is the minimum time. So basically it means that it is fixed amount of time it takes no matter how much size of input we give. Then we have O of log n, and then O of n, and then I think we have n square. So yeah, so this is like they are in the ascending order I am telling. So yeah, so this is what about time complexity. And similar to time complexity, if we have to compare between the memory of the or I mean space required for the algorithm or code, so that we measure using the space complexity.
Mm-hmm.
So in this case also O of 1 is like if the algorithm is using any fixed amount of a space, so no matter what the input we give. So yeah, this is what is the space and time complexity. Yeah.
Okay, okay. Okay, so what is JIT compiler?
JIT compiler, right?
Yes.
Yeah. So JIT compiler is basically the part of the JVM.
Mm-hmm.
So here, whatever the methods are being executed again and again, so they are kept separately and then further converted to the machine codes. So this is the purpose of this JIT compiler. So ultimately, it makes the Java code more optimized, and also it becomes more optimized to run. Yeah.
Okay, what is fail fast and fail safe?
Yeah. Fail fast and fail safe. Whenever suppose any collection is there and we are trying to iterate it within the iteration, suppose if we modify the that collection, so in that case it gives the concurrent modification exception. So this is called fail fast.
Mm-hmm.
So fail safe means in order to get rid of this, so we have some ways how we can prevent this. So that we say that it is fail safe. For example, suppose we have array list, right? So we have we what we can do that we can use copy on write array list if suppose we have to get rid of fail fast situation. So similarly, we can also use concurrent hash map in case of hash map. So basically, under the hood, a clone is created, and whatever the iteration we perform, that iteration is performed on that clone. So yeah,
Okay, what is immutable class?
yeah, immutable class is something using which we can create the immutable object, and the object which is created. So once this object is created, then we cannot change the value of instance variable. So basically, the object cannot be modified once they are created. So for example, we have a string, integer, long, right? So they all are immutable classes. Yeah.
Okay, so why we use immutable classes? So what is the purpose of it?
Yeah, that is required for security purpose mostly. Also, it provides thread safety. So for example, any string is there, right? So if suppose we want to change the actual its object, So
Mhm.
that is not possible once we do that. Um, so any kind of malicious or unintentional modification cannot be done. So this basically makes it more secure. Also, since immutable objects cannot be modified, so they are inherently thread safe and can be shared across multiple threads. So without any synchronization. So we don't have to basically externally synchronize it to make to ensure the thread safety. So yeah,
Okay. Can we create our own custom immutable class?
yeah, we can create.
Okay. Can you tell me the steps?
Yeah, first of all, we make the class as final.
Okay. But
Then
why?
we make the variables
Wait,
as
wait.
private.
So why we make the classes final? Can you keep on explaining the purpose also?
Yeah, method of the class should not be overridden by the subclasses. So to ensure that we can, the only way is like we can make the classes final, right? Otherwise, its methods can be easily overridden. So that is the reason why we make the classes final. Then we make all the variables as private and as well as final. So we make it private and final because if the field is of private type, then its value cannot be changed because it is final also, right? So
Suppose if the
uh,
field is holding the reference to another object, then
yeah, so uh, if it is holding the reference to another object, then we have to declare that field as well as final. So that means that its reference also cannot be changed.
okay, 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 go ahead.
Yeah, then we initialize all the fields in the constructor. Then we don't provide the setter method or any other method so which can change the state of an object. So we can only provide the getter methods to access the value.
Okay. So what if the field is object? So one of the variable is object. In that case, what you do in immutable class?
Yeah, in that case, we can make a deep copy inside constructor.
Okay, what if we use the any collections as a variable in the custom immutable class? Let's say we have list of students. Okay, that is one variable we are using, list of students. So what you will do for this?
Yeah, in that case, also we will make it final, but apart from that, we will also make a clone of it, I think. B- Sorry, we will make a clone of it, and we will create a copy of the that student list to that clone list, and that we can pass into the get students. So suppose the get students we are writing, so in that case we can pass this cloned one instead of passing the original object, so that if anyone is trying to modify that, they should not be able to modify it. Yeah.
Okay, what are the design patterns you are aware of in Java?
Yeah, I'm aware of factory, singleton, builder, then proxy. So yeah, I'm aware of these design patterns.
Okay. Have you worked on builder design pattern?
Yeah, I have worked on it. Suppose we have a class with many attributes, and if we want to create an instance of it using many parameters, so there are the chances that it becomes very much confusing and messy. So to get rid of those kind of problems, So we have builder design pattern. So in this case, we can create the instance in a single line. So for example, suppose we have a let's say we have a phone class. Okay, so that phone will have various properties like OS, RAM, its color, its a memory space, its processor, all that, right? So in this, first of all, we will have the phone class. It will have all those properties with private and final, and then we will have the constructor. So that constructor will be private to restrict the direct instantiation. Then we will have another phone builder class. In this also, all the members we will have the private final. We can write the setters for all. So like we can say public phone builder set OS, and we can pass the parameter inside that, and we can return this in that setter method. And then we have to ultimately write get phone in the end. So we can just return new phone, and there we can pass all the objects like OS, RAM, processor, so all that we can pass there. And then in the main, whenever we are going to call, so we can simply say new phone builder dot set OS, then we can give OS name, and then set RAM, we can give the value, and directly we can say dot get phone. So it will give the instance altogether, so we don't have to do it separately for each property. So yeah, so this is the benefit we have. Yeah.
Okay, what is hash map?
Yeah, HashMap is the part of Java collections framework. So in this we store the values into the form of key value pairs. So we have unique keys in that. The order is not guaranteed also. So if we want to insert the key value pairs into some order, in that case we can go for the linked hash map. So yeah.
Okay, what about null? Can it store null?
Yeah, basically it allows one null key and multiple null values.
Okay, what is the time complexity of it in hash map?
Time complexity, I think it is O of 1.
Okay, okay, fine. So in Java 8, why streams are called lazy?
Yeah, in Java 8, streams are lazy because whatever the immediate operations uh, we write, right? So that are not evaluated until and unless we write the terminal operation. So we have various terminal operations, right? Like collect, then we have count, sorted, mean, max, for each, right? So until unless we are not going to add this terminal operation, so the whole evaluation will not start. So basically these operations are lazy, we say, because they do not execute immediately. So yeah, so this filter map and all will only be evaluated whenever we have the terminal operations. Yeah.
Okay, so we will start with Spring Boot.
Yeah.
Okay, so why do you think that Spring Boot was introduced? So what was the purpose of introducing Spring Boot?
Yeah, so basically in Spring Boot, we have been provided with auto configuration features. So earlier in Spring, we had to do many configurations manually, so that we don't have to do in case of Spring Boot. So it is done automatically. So doing this, it eliminates lots of boilerplate codes and configurations. So the developer has only to focus on the business logics, not on the configuration and all. Then we have embedded server also with Spring Boot. So we don't have to externally add the uh, war file with any server externally. So Yeah, so that is also one. And then some functionalities like actuator has been provided. So using that we can monitor the health and metrics and info of all the Spring Boot applications which has been deployed. So that is also one thing. And also while adding the dependencies in Maven or Gradle files, we don't have to worry much about the versions of the suppose dependencies, whatever dependencies we are adding. So instead we can only focus on the like the main jar which we want to add. So it is handled automatically by Spring Boot. So yeah, so these are the advantages we have.
Okay. What do you mean by these jar versions in the dependencies? As you said, right? Can you explain a little bit more?
Yeah, I mean using Spring Boot starters, for example, the automatically the configuration in the Spring Boot is managed. So basically, this automatically ensures the version compatibility. So like Spring ensures that whenever we are adding the dependencies of any third party libraries to our project, so they should be compatible with each other, right? So all these checks are done by Spring Boot. And also this Spring Boot Starter Web or Spring Boot Starter JPA, right? So they have like pre-configured dependencies. So that include all the commonly used libraries for any specific purpose. So for example, it will automatically add the correct version of Hibernate, Jackson and Spring MVC and all jars. So we don't have to worry about the versions of it. So yeah.
Okay, okay. So suppose in Spring Boot application, you want to send the status code as 404 and you are getting any kind of some exception. Okay. So how you will do this?
Yeah, we can do this using add controller advice with at the rate of exception handler annotation.
Hmm.
So we can use this global exception handler to handle this 404 exception. So we can write a custom exception class first.
Mhm.
So that will have the 404 scenario and it should be accepting the message which we have to pass on. Then we can further implement the custom exception handler. So we can use these two annotations add controller advice and add exception handler. So as soon as through the controller any request comes in, so that based on some whatever the special condition is there, based on that condition we can just throw this custom exception whatever we have written with the message inside that. So yeah, that way we can throw
Okay,
the
what is the core container in Spring?
core container IOC.
Yes. Go ahead.
Yeah, IOC is the core container of Spring. So this container basically will create the objects and as soon as we start our application. So basically it manages the complete life cycle of the objects like from the creation till its deletion. So basically this Spring container uses dependency injection to manage the components that make up the application. Yeah.
Okay, what is the difference between controller and REST controller?
Yeah, REST controller is basically the combination of controller and response body. So in Spring Boot, mostly we use REST controller. So controller also is used for the like web applications like Spring MVC and all. That so suppose the return we have to do some model view. So in that case, we go for the controller. So REST controller, like whenever we are building the REST full APIs. So we need to return suppose JSON or XML data, then we go for the like REST controller. But whenever suppose we are developing the traditional web application where we have to uh, send the data to the views using the model view object, so in that case we can go for the controller.
So in microservices, what is circuit breaker pattern? Have you ever used it?
Yeah, circuit breaker pattern I have used it. So it is basically used whenever any microservice is trying to reach out to another microservice, but the another microservice is not able to respond because of some reason. The reason can be anything, either it is down or it is not responding for any reason. So we write a circuit breaker a pattern there. So under that we write a fallback mechanism. So basically this fallback mechanism we can mention the method name, and that under that method name we can further write the logic, like if suppose that a specific microservice is not reachable, then what we want to return. So instead of relying on the microservice, we also have a backup plan, we can say, in case of the failure. So basically this protects the system from the cascading failures. So like whenever after trying for the repetitive calls, if still the another service not reachable, so in that case this circuit breaks and it goes to the fallback method, and that is returned. So yeah.
Okay, so in microservices, what you do to make it scalable?
Yeah, so microservices normally we make it horizontally scalable, and for that we can use the tools like Kubernetes. So based on the application's specific its load and its performance need, we decide that how much scaling we want for an application, so how many instances we want. So we create that many number of instances as per the whatever the load comes to the specific server. So to balance the traffic, whatever is coming, we can use the load balancer or an API gateway. So based on the various algorithms, again these API gateways or load balancers send or routes the request to the different types of instances. Like suppose one of the instances is heavily occupied, then it will route to the those instances where the traffic is less. So yeah, so this is how we perform scalability in microservices.
Okay, so what is this API gateway?
Yeah, API gateway is an entry point, we can say, for all the requests which are coming to access the microservices. So it performs various tasks like request routing, as I said earlier, then load balancing, security. So all these are done here. So basically this is the way of providing the single endpoint to the client, which client can access, and he or she can perform the various operations, and we can hide the complex architecture or multiple services behind that. So instead of calling multiple services for a single business request, the API gateway can aggregate data from several services into one response. So yeah.
Okay, so in your microservices, how do you perform the logging and monitoring?
Yeah, logging and monitoring we perform using a centralized logging system called ELK stack. So that basically stands for Elasticsearch, then Logstash and Kibana. So basically this gets or aggregates the log from all different services of the microservices whatever we have, and it makes it easier to trace the issue across all services. So at one single point we can see all the logging from the all different services. And for monitoring purpose, I use actuator, and that actuator is kind of, it provides like some set of URLs endpoints which we can hit to get the information like info, metric and all. And also Prometheus is there, so that is combined with Grafana, so that for the visualization purpose and metrics we can see. So visually we can see using this technique. Also we use Jepkin in the distributed tracing. So yeah, so these are the ways we do it.
Okay, suppose you have a table and it has grown so huge that any insert, update, or delete, or any query you are performing, it is going to take lots of time. Okay? So now how you will overcome this?
For this kind of situation, we can go for the creation of indexes. So we can apply indexing on those columns which are being frequently queried. Then we can also use the partitioning of the table. So like suppose there are 10 columns, then we can partition it based on like whichever, I mean we will have to decide. We will have to architect it whether like maybe one table will have the like 4 columns and another table can have the another 6 columns based on the requirement. We can also have the situation like half of the data we can go with the table A, and the remaining of the data we can move to the some different table, like whichever, suppose the latest data is being fetched, so we don't have to query the whole table, right? So latest data we can put to the another table, and older data we can put to the some different table. So like this also we can plan. Apart from that, we can also see the queries and we can try to optimize the queries, and also we can use caching mechanism. So like suppose frequently we are querying some specific data, so we can add that to cache. So instead of directly hitting the database, we can get it from the cache. So yeah, these are the ways we can optimize our table.
Okay, can we apply indexing on all the columns of the table?
No, we should not do that. It will ultimately slow down the process more. So we should do only for those columns which are being queried more frequently. So yeah.
Okay, but why so? So why we cannot apply indexing on all the columns?
Yeah, like every time any entry we are making to the table or any modification we are doing, so all the indexes associated with that affected columns, so it must be updated to the reflect the change. So this is not like a standard practice, and this can be like very costly in terms of wherever it is deployed or its timing and all. Also, this indexing actually requires additional space where like it is kind of dictionary we can say. So for dictionary also we have like first 2 pages, right? So which is kind of tells the whole information about the dictionary. So similarly indexing also requires some additional space as well. So if we are going to perform the indexing on all the columns, so we obviously we need more spaces to store that. So yeah, these are the reasons we should not do indexing on everything.
Okay, have you worked on NoSQL?
Yeah, I have worked on it. I have worked on MongoDB.
Okay, how it is different from the traditional databases?
Yeah, we have RDBMS. So that is relational database, and this NoSQLs are non-relational databases. In case of relational databases, we will have some relationship between the tables based on the columns between the tables. But in case of NoSQL, so we will have the documents, and it is like useful whenever we have the items like television and books or different types of properties are there. So all that we can keep under the same document. So because they all have the different properties, right? So that all we can keep under the same document, but this is not the case with when we are using the relational databases. So yeah, so this is mostly we have with relational and non-relational databases.
Okay, okay.